Okay, friends, in this last video, I want to kind of take a look at this idea of independent versus dependent trials. And I want to see not just how they operate in a controlled environment like a casino, but also how that same idea applies to probability in our daily lives, and how pretty much anything in life is like a bet in a casino. It's just harder to measure. So let's start in the casino. A perfect example of a casino game that represents independence from trial to trial is craps. You throw a pair of dice. The dice do not remember what happened on the first roll if you pick them up and roll again. That's completely independent, roll after roll. That doesn't mean that people don't have fun at craps tables. They believe in things like hot hands, and they believe in things like lady luck, and that's all very well and good. But as we'll look at in the next video, those kinds of beliefs in lady luck and hot hands and whatnot are nothing more than random clumps, as you've already seen. Dependent. An example of a good dependent game is blackjack. Okay, so pretty much any casino game that involves dealing cards out has to be dependent, just like Russian egg roulette. Once the ace of spades, for example, is dealt out, that impacts the other cards in the deck that have not been dealt yet. So what this player is holding in his hand therefore impacts the next hand, which means the next hand is dependent upon the first hand. So here's an example of an independent game, craps, and then a dependent game, blackjack. Another example of an independent game is a one-armed bandit or a slot machine. These things are programmed to be random, and they have to be random. Otherwise, casinos lose money on them. As a matter of fact, this picture was taken from a news article in New Jersey when they were actually programmed wrong, and people took advantage of the incorrect random programming, and they actually made too much money on them. Each pool of these slot machines handles is completely independent of any other pool of the slot machine handles. In other words, a slot machine is nothing more than a very fancy vertical set of dice. Back to dependent, another classic casino game, poker. Poker, I mean, you can see the cards are laying out on the table, and chances are you're never going to see a royal flush in real life. But the idea is that these cards being out means that they cannot be anywhere else. If you roll a 7 on a pair of dice and then pick up the die and roll again, you can roll a 7 again. But if that queen of spades is right there, it cannot be anywhere else. So the cards here impact cards down the row, which means the cards down the row are dependent upon the cards that happen here. Okay, and one last independent game is the roulette wheel. This is one of my favorites because as I've walked through casinos later in life, I've noticed something. Casinos often have TV screens above roulette wheels. And what it's doing is it's actually showing you what has happened on the roulette wheel recently. I think it's a brilliant move that the casinos do this because, number one, they give people a false sense that they are collecting data in a meaningful way. But what people that are gambling don't realize is that doesn't mean anything. This wheel has 38 spaces on it. Some are red, some are black, and some are green. You can't see the green ones in this picture. So essentially, this wheel is a 38-sided die. Literally, that's all it is. It's a very fancy 38-sided die. But nobody puts a TV screen with roulette monitoring next to a craps table. For some reason, the roulette table seems to attract these things called monitors, and people think that they're actually telling them something. It's brilliant from the casino's point of view because the casino makes players think that they're getting an advantage, and the casinos know that you're not getting advantage. Trust me, friends, any of these games a chance, the independent games, you cannot beat them in the long run. You can't. You can beat blackjack and you can beat poker if you know how to card count. There's great books and movies about that. You cannot beat craps. You cannot beat a one-armed bandit. You cannot beat roulette. If you could, they wouldn't be in a casino. That's the lesson. Let's look at an example of probability in daily life. Now, I mentioned earlier in the video that pretty much anything you do in life is gambling. I mean, you could fall and break your leg getting out of bed in the morning. There's a risk. It's a very small risk. One of the classic questions I like to ask my students is, what's the chance when I walk across a crosswalk on COCC's campus, what's the chance I'm going to get hit by a car? Nobody ever knows because it's a hard question to answer. So what I then ask them is, well, isn't it 50-50? I either do or I don't. And they scratch their head a little bit because they know that's not right. It's not 50-50. Thank goodness, I'd be dead multiple times over. But it's hard to approximate probabilities like. One of the big things for me is bike commuting. That's how I get around. People often ask me, why do you bike commute? It seems like an extraordinarily dangerous way. I mean, you're out there, you're exposed, you're in the weather, cars are going to hit you, blah, blah, blah. I get all kinds of reasons. And I ask them, have you ever measured the risk of dying riding a bike versus dying driving in a car, for example? And nobody ever has. They just assume that riding a bike is more dangerous. So I decided to do some digging. And one of the first hits I got was bike commuters are dying in record numbers. Now, I know better than to trust the headline, so I dove deep. I started looking, and the League of American Bicyclists, I respect them quite a bit. They collect wonderful, wonderful data that we can dive into. 840 cycling fatalities in 2016. The first time the annual death toll has crept above the 1991 figure of 836. So we get it. I'm betting that roughly 850 or so cyclists die every year. Okay, a couple questions come to mind. First of all, were they all bike commuting? What were they doing? What kind of cycling were they doing? Were they bike commuting? Were they mountain biking? Were they downhill mountain biking? Were they jumping their bikes off of rooftops? So that leaves a lot of questions. But you know what? I'm going to just go ahead and assume that all of them died using a bicycle as transportation, bike commuting, so to speak. I'm assuming because it's in the bike commuters headline. But then that told me something. 840 people dying in a year. That's a lot of people. But orders of magnitude more people die from other reasons besides bike commuting. We have to be able to metric that 840 against something else. So I kept reading, and I found some interesting stuff. The bicyclist fatality rate, and check this out, cyclist deaths divided by the total number of cyclists. So this was interesting to me. I kept digging at this point. And further in the article, it talks about census tracking people who claim biking as their primary mode of transportation. So, and then they give us a couple years. In 2012, 734 cyclists died and about 865,000 people were bike commuting. That's a very, very small percentage, less than 1 in 1,000. And then here we keep going. 840 cyclists died and 864,000. Again, less than 1 in 1,000. And we keep going and keep going and keep going. And then it says, over the past decade, there's been a roughly 6.4% increase in the number of people bike commuting. But then something hit me. As much as I like the idea of using these numbers to form a percentage, we can't. First of all, there's about 1 million bike commuters. The average is about 15 miles per week, year round. That's from the League of American Bicyclists. They told me the exact same thing. So what I did was I worked out how many miles that was total. So if you multiply that million by that 780, you get 780 million total bike commuting miles. Okay, so now we know how many miles are traveled by all the bike commuters. There are also 840 roughly killed every year. So I can approximate the rough probability of death via riding a bike by simply dividing the deaths by the miles. Now, granted, the unit now is deaths per mile traveled, but I think that makes the most sense. It's a per capita, if you think of it that way. So roughly, it's 1 in 1 million. 1 death per million miles traveled, which is a pretty small number, a death per million miles traveled. But we got to compare it to cars because, you know, people that tell me I shouldn't bike commute are often telling me you should just drive to work. It's probably safer. Okay, well, let's take a look. So according to the data I was able to dig up on car commuting, 3 trillion total vehicle miles are driven annually. Now that I couldn't tease out car commuting miles versus just driving miles in general. For example, people going on vacation. That's not commuting, that's just going on vacation. And you would imagine that people that go on vacation probably drive many more miles than people driving to work, but that might not be true. I don't know because I couldn't tease it out. So I'm just going to use the entire 3 trillion total vehicle miles as my denominator. The National Transportation Safety Board tells me about 100 people die every day in car crashes, about 40,000 people a year. Okay, so really simply, you could divide those two numbers just like we did with bike commuting deaths and get a rate of death for car commuting, which, as you can see, is 1,000 times smaller. Instead of 1 death per million miles for bikes, it's 1 death per billion miles for cars. So maybe my friends have a point. I mean, I just proved it, right? I just proved that on average, bike commuting is 1,000 times more likely to kill you than car commuting. But I am not your average bike commuter. I already mentioned earlier that I don't travel the average number of miles. I travel about 7 times more than average, which you might say, well, that's just going to speed up your death because you're going to get to that million mile mark quicker, which is one way of looking at it, I guess. Another way of looking at it is the other ways that I kind of buck the trend for bike commuting. Many bike fatalities. Very often, the bikers that die are caught in a tricky situation where they put themselves between a car and a sidewalk, or the car and another car. In other words, they get themselves to be invisible to cars. So what I do very often is I add things to my bike, like red lights, white lights. I've recently added a green light to my helmet because I noticed that green light does a very good job of catching cars' attention in low lights. I've added spoke covers that are reflective, so that way cars that are coming at me, like in a T direction, will see me more clearly. I'll often take longer routes into work because those routes will take me into less vehicle traveled areas. So the average of 1 death per million miles is just that. It's an average across all bike commuters. But I am definitely of the opinion that you can change that average for an individual by simply being more alert. To paraphrase The Princess Bride, I always assume every car is trying to hit me. That's why I'm still alive. So the reason I bring this up is probability is really cool. And it does a really good job of describing the frequency of events. The danger, of course, is when averages are taken at face value and applied to every single person, which is a huge mistake. You shouldn't apply an average to every single person. What we'll look at in our last series of videos is a way to take those averages that we can trust and fuse them with statistics to see how probability and statistics kind of influence and color our everyday lives in ways you probably haven't even thought of yet. So that's next, but let's try some homework first on this.